Hey, Ivan is here. Everybody says Java is old. Everybody says Node is faster than people think. So today I built the same backend twice. Same store, same endpoints, same Docker limits. And then I threw a traffic at both of them until one started making excuses. And the results were uncomfortable. First, we need... For Java, I generated the project using Spring Initializer. I selected Gradle with Groovy, flexible, fast for iterations, and the trendy choice that actually feels good in modern Spring projects. Spring Boot 4.0.6. Then 3 dependencies. Spring Web to expose endpoints, Spring Boot Actuator to expose runtime metrics, Prometheus so Grafana can collect those metrics. Download, unzip, done. Congratulations! You now own 12,000 files. Build.Gradle is basically the project's command center. It contains dependencies, build, packaging, runtime configuration. For Nest, I used PNPM. PNPM stores packages efficiently and links them instead of duplicating everything. Faster installs, less wasted disk, more room for your bad decisions, time to inspect the... This is not a benchmark of frameworks doing different jobs. Both applications do exactly 3 things. Get products, buy a product, track total profit. Product is a Java record, small immutable object, constructor, equality, nice and compact. Nest uses an interface, even simpler, compile time structure, runtime disappears. Products are stored in memory, static list, no database, find by ID returns optional. Java basically says, you may not get a result, handle it. Nest copied a lot of ideas people already liked in Spring. Controllers, dependency injection, decorators, very familiar if you switch stacks. But in services, they are different. This difference is fun. Spring uses atomic long. Multiple threads may update profits simultaneously. Node runs JavaScript inside one event loop, so simple addition works safely here. Different runtime, same business outcome. Now it's time to build. Both images use multi-stage builds. Build inside one container, run inside another. Smaller images, less junk, better deployment. Now both stores are alive, which means it's time for... To test this, I used Grafana K6. K6 is basically thousands of imaginary customers. They visit, buy random products, repeat, customer enters, customer makes questionable fashion decisions, customer spends money. Every minute, more users arrive, until we reach 10,000 requests per second. Nobody survives infinite traffic. We're here to find the ceiling. This takes 10 minutes in real life, but thanks to the power of editing. Okay, now this gets interesting. This is the internal heap, the actual sandbox where objects live and die. Look at JavaScript. Flatlined, sitting comfortably between 16 and 32 megabytes, almost elegant, and Java, it is an absolute roller coaster, spiking, dropping, exploding up to 197 megabytes. To an untrained eye, JS is winning. It looks stable, efficient. Java looks like a chaotic mess, but that chaos is actually signs of life. Those sharp drops, that's Java actively cleaning up its garbage to survive the incoming storm. JavaScript isn't cleaning up, because JavaScript isn't even invited to the party yet. Let's look at the actual throughput to see the real damage. And here is the reality check. JavaScript hits a ceiling at 12.13. It caps out at exactly around 3,000 requests per second. It cannot go higher. It just coasts. Meanwhile, Java looks at that ceiling and flies right through it, peaking at 12,200 requests per second, 5 times the throughput of JS. If JS is flatlining at 2,500, where is the rest of the traffic going? The load tester is pushing 1,000 virtual users. Where did they go? JavaScript dropped 1.5 million iterations. The users are stuck in a queue, suffocating. Average response time for JS 316 milliseconds. Java 34 milliseconds, 8 times faster. Why did JS hit a hard wall while Java kept climbing? The answer is hidden in the heartbeat of the engine. Let's look at the stalls. This is where the illusion completely breaks. Java is stalling for 28 milliseconds under peak load because it's doing heavy garbage collection, but it recovers instantly. Now look at JS. The event loop lag stays low, only 2.5 milliseconds. If the event loop isn't lagging and the heap isn't growing, why is JavaScript failing to handle the requests? Because Node is single-threaded. At 2,500 requests per second, that single thread hit 100% CPU utilization. It didn't lag, it didn't sweat, it just quietly started dropping your users on the floor. Let's see exactly how hard both engines pinned the processor. The final proof here. JavaScript hits 100% of its single-thread capacity plus overhead, 1.23 cores. That is its absolute physical limit. It has no more room to breathe. On the other side, Java simply utilizes the multi-core architecture. It scales up to 2 cores. It does the work. JavaScript looks clean on memory metrics because it stopped accepting work. Java looks heavy because it actually delivered the results. The number matters. Dropped iterations means the traffic arrived faster than the app could keep up. K6 simply stopped waiting. And this surprised me not because Java won, it's clear, but because it wasn't even close. One runtime looked relaxed, and the other started negotiating, which leads to the... Does this mean Java is better? No. It means this workload favored Spring. If I need high sustained load, predictable latency, heavy backend system, I would probably reach for Java. If I need rapid development, full TypeScript, one language everywhere, backend, frontend, and smaller team velocity, Nest felt easier. Java felt stronger. But if traffic doubles tomorrow, I know which container I open first.